Hi everyone, welcome back to this video series on cryptocurrency. Script with control flow conditional clauses. One of the powerful features of Bitcoin script is flow control, also known as conditional clauses. You are probably familiar with flow control in various programming languages that use the construct if then else. Bitcoin conditional clauses look a bit different but are essentially the same construct at a basic level. Bitcoin conditional opcodes allow us to construct and redeem script that has two ways of being unlocked, depending on a true-false outcome of evaluating a logical condition. For example, if X is true, the redeem script is A and the else redeem script is B. Additionally, Bitcoin conditional expressions can be nested indefinitely, meaning that a conditional clause can contain another within it which contains another, etc. Bitcoin script flow control can be used to construct very complex scripts with hundreds or even thousands of possible execution paths. There is no limit to nesting, but consensus rules impose a limit on the maximum size in bytes of a script. Bitcoin implements flow control using the if, else, end if, and not if opcodes. Additionally, conditional expressions can contain Boolean operators such as bool and bool or and or not. At first glance, you may find Bitcoin's flow control scripts confusing. That is because Bitcoin script is a stack language. The same way that 1 plus 1 looks backward when expressed as 1 ADD, flow control clauses in Bitcoin also look backward. In most traditional procedural programming languages, flow control looks like this: if condition, code to run when condition is true, else code to run when condition is false, code to run is either case. In a stack-based language like Bitcoin script, the logical condition comes before the if, which makes it look forward like this: condition if, code to run when condition is true, else code to run when condition is false, and if code to run is either case. When reading Bitcoin script, remember that the condition being elevated comes before the if opcode. Conditional clauses with verify opcodes. Another form of conditional is in Bitcoin script is any opcode that ends in verify. The verify suffix means that the if condition evaluated is not true, execution of the script terminates immediately and the transaction is deemed invalid. Unlike the if clause, which offers alternative execution paths, the verify suffix acts as a guard clause, continuing only if a precondition is met. For example, the following script requires Bob's signature and a pre-image secret that produces a specific hash. Both conditions must be satisfied to unlock. Hash 160 expected hash equal verify Bob's pub key check. To redeem this, Bob must construct an unlocking script that presents a valid pre-image and a signature, Bob's sig hash pre-image. Without presenting the pre-image, Bob can't get to the part of the script that checks for his signature. This script can be written with an if equal hash 160 expected hash equal if Bob's pub key check sig end if. Bob's unlocking script is identical. The script with if does the same thing as using an OP code with a verify suffix. They both operate as guard clauses. However, the verify construction is more efficient using one fewer OP code. So when do we use verify and when do we use it? If all we're trying to do is to attach a precondition guard clause, then verify is better. If, however, we want to have more than one execution path flow control, then we need an if-else flow control clause. Using flow control in scripts, a very common use for flow control in Bitcoin script is to construct a redeem script that offers multiple execution paths, each a different way of redeeming the UTXO. Let's look at a simple example. We have two singers, Alice and Bob, and either one is able to redeem with multisig. This would be expressed as one of two multisig script. For demonstration's sake, we will do the same thing with an if clause. If Alice's pub key check sig, else Bob's pub key check sig end if. Looking at this redeem script, you may be wondering, where is the condition? There is nothing preceding the if clause. The condition is not part of the redeem script. Instead, the condition will be offered in the unlocking script, allowing Alice and Bob to choose which execution path they want. Alice redeems this with the unlocking script Alice sig 1. The 1 at the end serves as the condition true that will make the if clause execute the first redemption path for which Alice has a signature. For Bob to redeem this, he would have to choose the second execution path by giving a false value to the if clause, Bob sig 0. Bob's unlocking script put 0 on the stack, causing the if clause to execute the second else script, which requires Bob's signature. Since if clauses can be nested, we can create a maze of execution paths. The unlocking script can provide a map selecting which execution path is actually executed. If script A, else if script B, else script C, end if. In this scenario, there are three execution paths: script A, script B, and script C. The unlocking script provides a path in the form of a sequence of true or false values. To select path B, for example, the unlocking script must end in 1, 0, true, false. These values will be pushed onto the stack so that the second value, false, ends up at the top of the stack. The outer if clause pops the false value and executes the first else clause. Then the true value moves to the top of the stack and is evaluated by the inner nested if, selecting the B execution path. Using this construct, we can build redeem scripts with tens or hundreds of execution paths, each offering a different way to redeem the UTXO. To spend, we construct an unlocking script that navigates the execution path by putting the appropriate true and false values on the stack at each flow control point. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.